In this video, the MOES automatic transfer switch switches you between your solar inverter and the grid. It only costs around $100, so it is a very popular item. If you use it as it is designed, however, there are situations where it can prove to be quite dangerous. But with a few simple hacks, it can have some very cool and useful applications. Here's how it works. First, take the AC outputs of an inverter and connect it to the inputs right here marked inverter. And notice there's a hot and a neutral. And next, take the AC power from the grid and connect it to this, which is called public power. And again, hot and neutral. Next, connect the things that you want to run off of this, the load, from the middle connectors marked output. Now, the battery that you have connected to your inverter, you will also take two leads off of that battery and connect them right here underneath. Now, this will supply the power that runs this unit. And the voltage of this battery determines the power source. If the battery voltage is above what's called the low voltage level, then you will be running on the inverter. If, however, you run the battery down below the low voltage level, the automatic transfer switch will disconnect from the inverter and connect you to the grid, therefore protecting the battery. Press this middle button to enter edit mode. Use the up and down arrows to make changes to the voltage. Then you hit the middle button again to save. This is our main home screen. Notice it says 48 volts over here. It auto senses whether your battery is 12, 24, or 48 volts. The battery is currently at 52.6 volts. We press this center button and we're now on the low voltage switch page. When the battery falls below this voltage, we will switch from inverter to grid power. Use the up and down arrows to change this voltage in increments of 1/10 of a volt. To save the setting, you hold the center button until it jumps back to the home page. So what I'm going to do to make this thing drop in voltage is I'm going to turn on a little space heater I have over here. And watch. There we go. And it just switched over to grid power. Now, to get this to switch back over to the inverter, we will use something called the high voltage switch. When the battery gets above the high voltage level, we will reconnect to the inverter for power. To get to the high voltage switch, you press this center button twice. And I've got this set for 53.5, and I'm reconnecting my PV to recharge the battery. You can see the little arrow here. We're still on grid. And there, we just switched back over to the inverter. Okay, so this is actually a pretty cool little device. I used it successfully for several years with my first battery system, which these were recycled Chevrolet Volt lithium-ion batteries, and I did not have a BMS on it, so I used this to protect the batteries from being drained down too far. All that being said, there are some very dangerous situations that could arise from using this, so let's take a quick look. This is the user manual. Okay, so here are the technical specs, and they're showing this being able to be used for 120 volts or 240 volts. We're going to come back also in a minute to these ratings because there's no way that you're going to be able to get that much power through this thing. So let's go back up here. This is showing it wired for 120, where you're using line and neutral or hot and neutral through the switch. They don't even show grounds, but I'm assuming you run all your grounds together in a breaker panel. But to hook it up for 240 volts, then it shows line 1 and line 2 going through this switch and all of your neutrals being tied together. So inside of this unit, this is the circuit board that runs the display and is the switching logic. This is the terminals where everything is connected, and these are just mechanical relays. The relay on the left is switching the hot circuits. The relay on the right switches the neutral circuits. Both of these are normally closed relays and they default to the grid. So when the power's off, or even if the battery is not connected, they default to the grid connection. So say the relay that's controlling the line 1 input were to fail, it would default over to the grid input. But your other relay that's running the neutral inputs or the line 2 inputs, this would still be coming off the inverter. So you have one leg coming from the inverter, one leg coming from the grid. And of course, this can cause all kinds of problems, burn up your inverter, burn up your equipment, who knows, burn up your whole neighborhood, but it's not good. Okay, the next potential problem is the fact that it's not aware of any problems with the grid input or the inverter input. A standard UPS backup system is always watching the grid input. And when the grid goes away, of course, it switches to battery. But this MOES unit is not aware of problems with the grid input or the inverter input. Say the inverter was putting out high voltage or the inverter shut down and wasn't running. This unit would be unaware that there was a problem. Now, there is a way we can take advantage of this, and I'll come back to that in just a minute. The third potential problem is that the internal wires cannot handle the claimed power rating. They showed you 5.5 kilowatts at 120 volts or 11 kilowatts at 240. So the internal wires here are all like 8 gauge, which I believe would only be around 3,000 watts at 120 and 6,000 watts at 240. So you would definitely want to keep your wattage below those numbers. There are some safe ways to use this MOES automatic transfer switch. And I think the safest thing to do is just use it as a battery cutoff switch. So you only hook up the inverter side of the inputs and do not connect anything to the grid inputs. And that's what I did when I used this with my early system, as I used the inverter input, but not the grid inputs. I have no wires at all connected over here to the grid input. So if your battery level goes below what you set before as your low voltage switch voltage level, then this switches from inverter to the grid, but there's nothing connected to the grid. So you've disconnected your inverter from your load, which keeps your battery from getting drained down too far. And a good use of this would be lead acid batteries that don't have a BMS, but you still want to keep those batteries from getting down below. And in case of a lead acid, you don't want it to go below 50%. You're automating the protection of the battery, so you don't have to keep your eye on it all the time. And the next situation that you might use this in would be batteries that do have a BMS, but you set this to shut down before the BMS does. So if your charging circuits for your battery are actually part of the inverter, an all-in-one inverter or a inverter charger, what happens is the BMS shuts down, which shuts down the inverter. So now you can't use your inverter to charge your battery back up. So now you have to use an external charger or a power supply or something to charge your battery back up. Okay, so to sum up this MOES automatic transfer switch, it has some uses, but it also has some potential problems. And I just wanted everybody to be aware of that. That wraps it up for this video. See you in the next one.